Alright, so this is some 3D artwork that I have made of the machine. I have it broken down into its main components, but with their combined movement capabilities, you can account for any type of movement throughout a three-dimensional environment. And I'll start with the spherical pods here, which are interactive immersion chambers that the passengers will enter. They are not transparent. This is just to show what's going on the inside. Now the size, the amount of passengers, and interior features can be customized for different uses. The passengers will either just be along for the ride with no control over what's happening, or they could be in complete control of what's happening. I have three examples here. This one has a single passenger on a motorcycle setup. The others have two passengers inside, arranged a couple of different ways. This one side by side, this one with more of a fighter jet setup with one passenger sitting behind the other. Each pod, regardless, will have either wraparound screens covering the inside and or specialized headgear for the passengers to wear. The visuals presented on these devices give the realistic impression of being in the middle of a digital modeled environment. These modeled environments will be ultra realistic, accurate 3D depictions of real places or imaginary. Now, the interior is then set up to be like that of a car, a helicopter, fighter jet, or on a motorcycle, or something special that I like to call free walk. Now, the possibilities are really endless. The pods have a sound system. They have special effects like temperature control, and other things like wind and fog and smells even. And they are equipped with a proper power supply. Each pod is placed on this mechanism called the roll system. This, working by computer control, positions the pod and its passengers for the correct environmental position and for correct G-force application based off of the visual data. These four mechanisms here will do the actual rolling, and with the combined movement capabilities, any pod position can be achieved. As you can see in these movements here, you have a barrel roll kind of maneuver where you're rolling left and right, and this has a 360-degree roll capability in either direction. And then you have a forward and backward flip like this, also with a 360-degree flip capability. So you can go all the way around. And then you have the left and right pivot, again with a 360-degree movement capability. And then if you combine any of those movements, the passengers can wind up in some very interesting positions. Now, while these movements are being carried out, everything is being held in place by this structure here. So it's going to kind of be like your eyeball in the socket. It can roll around in all directions, but it's not just going to pop out. So this structure holds the pods in place, also while leaving it free to roll with no resistance. And then this is showing what it looks like relative to someone my size standing next to this structure and I am 5'7", and I want you to keep in mind that everything is going to be built with the lightest weight and strongest materials used appropriately where needed. Now, the colors are just to help me when explaining what everything is. So the pod with its roll system and the socket structure is kind of sandwiched between these top and bottom green tracks here. And because the tracks are in a donut shape, you can add multiple pods. There's only one here, but I have two here positioned opposite each other on the track. And then I have 4 here, but you could have up to 8 pods in this design. If you want more pods, you just scale things up a bit. More pods means more passengers at once, or if the machine's purpose is for training, each pod could have a different interior setup, eliminating the need for multiple systems. One could be set up for helicopter training, one for fighter jet, one for a tank, and one for, say, a Humvee. You can really do pretty much anything. Now, these green tracks enable controlled centrifugal rotation around the purple middle structure, which is the tower. And by having the ability to control the rate of rotation, you can then apply controlled horizontal g-forces to a passenger's body based again off of the visual data. Now, this ability is what will accurately simulate the acceleration of something like a car or a jet plane and account for all horizontal g-forces that one may feel while moving throughout a 3-dimensional environment. Then, accompanied by the positioning of the passenger within the pod, you can then determine the angle in which the g-forces are applied. So all of this alone really gives you unlimited options of things you can do for entertainment purposes, but there's more. Now, what the purple middle structure, the tower, enables is the controlled ascension and descension of these components as a whole. So again, by computer control and based off of the visual data, you can account for all vertical g-forces one may feel when moving throughout a 3-dimensional environment. These movements can include free fall, rapid ascension, and really everything in between. The only limit you have to these vertical movements is the height of the tower, and that is determined by the customer's needs. So you could have a system like this with a 35-foot tower and a 20-foot diameter base. Or if you want things to be a little more extreme, you can increase the tower height to, say, 70 feet. "105 feet, 140 feet, and you can keep going. Another advantage you have, though, with the overall design of the system is that it gives you the ability to build the machine partially or completely into the ground. So it'll end up looking something like this. So if you build it into the ground, it enables even more vertical options, and it leaves a nice unobstructed view of the skyline. And it could go down into the ground pretty far. So with these components working together by easily reprogrammable computer control, your options are unlimited with a single system. So their small footprints make them easy to fit just about anywhere. You can have multiple systems in one relatively small area compared to something like that of a roller coaster, which takes up a generally large portion of land. Now, there are no simulators out there that offer these kinds of possibilities and accurate effects to a passenger, thus making this technology beneficial in many ways, not just for entertainment purposes, but for things like education, military training, and scientific study. In these areas, accuracy and unlimited options mean everything. Of course, there are many more details about how everything is working, but these are the basics.